Okay, so now we're going to talk about the interpretation of the results and a lot of important implications here and things to consider. So, if you've heard of statistical significance, you took stats with me or somewhere else, right? Statistical significance is this idea that when we look at our p-value, if it's less than a number, typically 0.05, we have statistical significance, and we claim like, yes, there is an effect, there's a relationship between variables, right? Usually this is typically celebrated, which is all fine and dandy, but it's not the whole story. Because sometimes something can be statistically significant, but it's not practically significant, or there's no meaning to it. So basically, what this means is even if something is statistically significant, like, is it meaningful? Meaning, would it be worth it to invest your resources, your time, your money, your human capital, based off of these findings? So you're going to watch a video for this week, but in it, the researchers explaining that, as an example, Common Core. So in education, for children, they have Common Core, and they want to see, is this effective. So let's say that we run an experiment and we randomly assign students to learn under this new Common Core, and then we randomly assign the rest of them to their traditional education, and then we give them an exam in the end, and we find that under this new Common Core, students earn about an 81, and then under their traditional education, they get an 80%. And let's assume that this is statistically significant, meaning, yes, the Common Core is effective and is a better way of educating the students in terms of their learning. Now, you would probably look at this and think, yeah, maybe it's statistically significant, but there is no way that we are changing our entire education system based off of a 1% difference. Like, we're just not. We're going to retrain all of the teachers. We're going to buy new textbooks. We're going to change the entire curriculum, right? That's just not practical. So that's another thing that you want to think about. Is just because something's statistically significant doesn't mean that you have to act on it, because it might not be practical. It might not be meaningful to do so. So okay, well, how do we assess this practical significance? There's a lot of different ways that you can do this. Sometimes it's the way that you can maybe interpret the data. Sometimes it means bringing in different people from your organization, maybe from finance, accounting, where they can help you do some type of cost benefit analysis, like how much is this going to cost to implement the change versus how much you could actually make off of this, or how much is it going to affect your organization. So I have an example based off of a research study that I did, where we were looking at assassination of leaders, heads of states in the world. And we collected the data, and we wanted to look at what variables affected the likelihood of it getting assassinated. And one variable we looked at, you can see down here, is social conflict. So there's a positive relationship, meaning that the more conflict, social conflict, there was within the people of that country, the more likely a leader was to get assassinated. And up here, we see these results. The results here confirm that social conflict was a significant predictor of assassination. There's our beta estimates, a positive slope, as we see here. And then there's our wonderful p-value. Yay, less than 0.05. Okay, so let's imagine that we're going to go now talk to all these heads of states. And, would we tell them, like, hey, you need to reduce your social conflict so that you decrease the likelihood of you getting assassinated? Okay, that's a whole other can of worms, but would that be practical? Would that be the one thing you would want the heads of states to focus on? Well, it's statistically significant, but also we had a huge sample. Maybe that's really affecting the estimate. So we interpreted this with the data. So we said specifically, going from a score of 1 to 5, because it was on a 1 to 5 scale, on social conflict, that increases the probability of getting assassinated from 0.056 to 0.549, which, okay, like, is that a big increase? Well, it is. It's an increase of 880%. So yeah, so having that that data and being able to interpret it and present it in a different way can help people make this decision in terms of, is it practically significant? Is it meaningful? Other things that you can do is you can look at what are called effect size. So Cohen's d, as an example, is a measure of effect size, where it basically tells you, like, okay, you found an effect, but is it small, medium, or large? And again, you might think, like, oh, so does that mean if I have a small effect, I shouldn't really act on it? Well, no, again, that it depends on your question, it depends on your industry, your data, what area you're in, right? If you were in the medical field and you found a drug that has a small effect on people's experience in terms of maybe, let's say, cancer, it slows down the spread of the disease or something, that small effect may be huge in the medical field. So it might be something that, even though it's a small effect, it's huge relatively speaking. But maybe for a business that wants to implement a change, there's a small effect. Is it worth, investing the time, the money, changing the infrastructure for a small effect? Not maybe not. So again, the Cohen's d or different effect sizes help you put it into perspective in terms of like how big is this effect that you're finding. So that's another way of looking at it. Speaking of effect sizes, I also want to talk about a sample size because technically, typically, the larger the sample you have, the more likely you are to get a significant result, which kind of makes sense conceptually because if your sample gets larger and larger, you're basically approaching the population size. And the more of the population that you have, the more data that you have to better understand the effect and what's really going on. But we can also look at this mathematically. Of course, I have to give this example. Um, so here's an example of just the t statistic, a t-test. And so here we might be comparing the mean of something to a new mean. So let's say that you work in an organization and you're doing customer satisfaction. You have a call center. So let's say that on average, when people call in, your sales reps, your customer reps, they can help on average maybe 10 people per hour. But let's say you put them through a new intensive training program where they learn how to handle calls, how to answer them, how to more efficiently tackle call problems. And let's say all of a sudden now they're able to help 20 people per hour. So in the numerator here, that's what this is. It's the difference. So the larger that this number gets, the larger this number is going to get. So that's what this numerator is looking at. And then the bottom here, the denominator, is it's really a measure of variability. So the more variability you have, the more you're basically not sure if there's really an effect or something going on. So a larger denominator is going to decrease your test statistic, which is basically going to say that there's less likely of an effect going on here. So we can actually look at the effect of sample size on our test statistic, or basically what ultimately is going to be our p-value. So let's keep all of these numbers the same in here except our n, our sample size. Let's assume the numerator is 100 for both of these situation scenarios. The standard deviation is 10, but we changed our n, or the square root of n, our sample size, from 1 to 10. Right, so all else equal, right? 10 divided by 1 is 10, 100 divided by 10 is 10, right? But if we increase our sample size, now it's up to 10, or the square root of 10. 10 divided by 10 is 1, 100 divided by 1 is 100. So you see how just by increasing our sample size, this test statistic actually increases. So this is something else we want to be aware of, because if you are ever looking at data, and you look at the sample size and it's something like, hey, there were 1,000 participants or 5,000 participants, I don't need to know anything else. I would be shocked if the results were not statistically significant. And again, depending on the study, the analyses that were done, all this or that. But that is a factor that can affect statistical significance. So that's an example sometimes where you if you have a huge sample size, your p-value is probably going to be 0.000001. Like, oh my God, it's so significant. But is it really meaningful, or do you just so happen to have like a huge sample size? I think sample size is also worth talking about because if you are someone who's a part of this, hey, we need data to make decisions in an organization, you also have to consider the fact that the more data you collect, even though you're getting more information, it comes at a cost. Right? Every time you ask someone, hey, can you participate in our research, you probably have to pay them. And then if not, if you happen to get free data, it still comes at a cost that maybe you have to still collect this. It might come as a cost somehow in terms of time, money, human capital, that sort of thing. So it's kind of maybe like we want a lot of data, but maybe not too much because it comes at a cost. So there's actually tests that you can do to determine what your sample size is. And this is related to the next topic of power. So power is the ability to detect an effect that exists. So power depends on a lot of things. One is sample size, right? The more larger sample you have, the more likely you are to detect an effect. It depends on your alpha value, your p, right? If you go from 0.05 to zero point zero 0.01, right, you're getting more precise, and so it's kind of harder to detect. So you have to think about that. It depends on the effect size, right? It's harder to detect a smaller effect than it is a larger effect. So a lot goes into power, but you can actually do power analyses before you do a study to figure out what your sample size should be. So the software is this software that I have is actually free, G-Power, and I just did a quick example using a t-test. Let's say that you have two independent groups, right? So maybe you have two websites and you want to see which one is going to result in more higher traffic or more people purchasing things or spending more time on your website, whatever your metric is. So you have two groups. You're using a t-test. Let's say that you're using your alpha as 0.05, right? That 0.95, your p-value you're looking at is zero point zero 0.05. You got your effect size in here. So you enter all these different numbers, and then when you run this, you come up with your total sample of about 200. So 100 people in each of the different conditions. So this is really helpful because one, you know ahead of time, like how much is this going to cost you? And is this even feasible before you even go through the entire data process? What if you're running a study and it comes out that you need a total sample of like 1,000 people to detect what you want to detect? And you don't have that type of money to invest in that type of research. Well, then you kind of got to start over at the drawing board. So power analyses are really effective for figuring out what is the appropriate sample size that you should have to detect an effect. Because otherwise, if you're just like, let's just collect a ton of data, you're more likely to find something that is statistically significant, which can kind of, affect your practical significance. Because sometimes people just focus on the p-value. Another thing that really goes along with this is this idea of phishing or p-hacking, and this is the idea that sometimes this does happen. It's unethical, and sometimes people don't mean to do it, but they do it. Is where they collect data, they run the analyses, and they don't get something that's statistically significant. And they're like, you know what? I bet it's because we don't have a large enough sample size. We don't have the power to detect the effect. Let's collect a little bit more data. So they got and they collect a little bit more data. Some of these observations we had to delete. So again, we need to collect more data because we didn't find an effect. And it's not because the effect's not there. It's just because, we don't have the data for it. So they got and they collect more data and then, oh, finally statistical significance. We knew it was there all along. But is there really an effect, or are you just collecting more data and more data until you just by chance happen to get something that's statistically significant? It's called p-hacking. It's unethical, and you want to avoid that. And again, maybe there really is an effect, and you happen to find it, but that's not the way that you should go about it. So, excuse me. That these are things that you want to think about as an analyst. Um, Trying to plan things ahead to find the effects when you need, using the resources, not oversampling, um, wasting time and resources. But then also, again, as a consumer or as somebody who is maybe a leader who's leading a project to collect data, to make decisions in your organization, these are things that you want to be aware of. You want to be aware of, hey, are you running a power analysis? What is our sample size? Can we afford that to begin with? All right, you found statistical significance. Is this practical? Is this something we can implement? What's the effect size? Right? What did you do with your data? When did you determine it was statistically significant? These are questions that you want to ask so that you best understand your data because the results, that's what's going to affect the decisions that you make, the policies that you change, the changes that you make in your organizations, those huge decisions, that ultimately is what you're doing this for. So you want to make sure that you're asking these questions. So I think that's mostly it that I have. But if you do have any questions about any of this content, as always, just reach out.